Today's webcast is featuring an interview with our special guest, Rich Crompton from Oak Ridge National Laboratory. Thank you, Rich, for hopping on. Today you have myself, Brett Zumwalt, as your host. I'm the field marketing manager for our secondary storage business and our federal sector as well. So I support a couple of the gentlemen on the phone today and many others behind the scenes. I spent about 5 years over at Arrow, supporting the VMware and Dell business before joining Quantum, and have several years of experience in the marketing role in the IT industry. Our main presenter today is John Petty, also from Quantum. He's our pre-sales engineer for our federal business. He's a federal systems engineer with about 15 years of experience and currently works as an architect on our public sector team. He currently lives in the DC metro area and supports currently our Department of Energy, NASA, EPA, USDA, and several other organizations. Also with us today, our special guest, Rich Crompton, system engineer from Oak Ridge National Laboratory. John and Rich will be going through a discussion where they will talk through the Quantum solution that Oak Ridge is currently using. And Rich has worked in the system administration enterprise storage management sector for about 15 years. He currently resides out in East Tennessee. He's currently supporting the mission at Oak Ridge National Laboratory. And then Jared House will wrap things up for us today as he walks through some of the architecture of some of our storage management systems. And Jared is an experienced pre-sales engineer focused on data protection, file system, and archive solutions. And for the past 12 years with Quantum, and before that with Lockheed Martin Aeronautics on their Solaris and data protection programs. He currently lives out in Northern Virginia and supports the Air Force and other special programs. All right, so as we get started here, what we wanted to do today is kind of talk through some ideas and the way that Oak Ridge National Laboratory came to find Quantum as a solution that fit well in their environment. We wanted to kind of hone in and make sure that we presented the customer point of view so that you guys understood the decision-making process and some of the other architectural things behind the scenes that might have impacted some of the decisions in that. So without further ado, I'd like to hand things off to John Petty, our system engineer for the federal sector, and Rich Crompton from Oak Ridge National Labs. Guys, you may take it away.
Great. Thanks, Brett. Appreciate it. Thanks, everybody, for joining today, and thanks, Rich. Good to see you. So, Rich, tell us a little bit about yourself and your history at Oak Ridge, and what does SNS do? That's the group you work for down there.
That's right. Yeah, so my name's Rich Crompton. I've got a background, as Brett mentioned, in Linux systems administration and storage management. I've been at Oak Ridge National Laboratory for about 8 years now, supporting the mission need, scientific mission of the Neutron Sciences Directorate. So we support 2 user facilities where scientists come from around the world to run material science type experiments using neutrons for more efficient biofuels and to learn a little bit more about the different types of materials that we use in everyday life. Last week, the facility that I support, the Spallation Neutron Source, came online, and our second user facility, the High Flux Isotope Reactor, actually comes online today to run experiments related to the COVID-19 proteins and to learn a little bit more about what's going on in the world today.
Great. So, Rich, way back when I first met you, maybe 3 years ago, you personally did not have any experience with StoreNext file system, but somebody on your team did, right?
Yeah, a colleague. He used an earlier version of the StoreNext file system about 10 years ago. He came from the oil and gas industry. When it came time to refresh our data file system, he kind of recommended that we look at StoreNext at least, and we looked at some of the major storage vendors as well as StoreNext, and it looks like they ended up meeting all of our needs.
All right, awesome. So when you were first looking at that initial quantum solution. You had another technology, and what were some of the driving factors in getting away from that and the things you were looking for in a solution?
Yeah, we had about a 1 petabyte file system. It was an open source Lustre file system. Everything, all of the experiment data that had been collected at the spallation neutron source up to that point was stored on spinning disk. As we continued to grow, we realized it was going to be pretty expensive to continue keeping everything on disk. So we worked with the Neutron Sciences Management to create a data management policy. That policy allows us to archive some of our older data that's kind of stale on the spinning disk off to some other medium. So we started looking at alternative high performance, parallel file systems that would meet our performance need for acquiring this neutron data. We needed high availability, and we wanted to be able to grow cost effectively by managing this archive of older stale data.
All right, great. So yeah, moving it off to a lower cost tertiary storage, regardless of what that was really a big driver. So you've been on StoreNext now for about 3 years. We're not going to be Pollyanna about it. We know there's some things you really like about it. Tell us about that, and where would you like to see some improvements?
Yeah, we've been running, like you said, in production for about 3 years now. Some of the positives, we haven't had much downtime at all. And a little amount of downtime that we've had was kind of brought on by ourselves with some misconfiguration early on. Support was one of the key reasons we ended up going with the quantum solution. With the open source solution, it was kind of on us to provide support for that file system. So we wanted a more enterprise-like file system where we could depend on a vendor and support for managing that important critical aspect of our environment.
Excellent. And you've had good experience in the support relationship with quantum?
Yeah, support's been a very big key in our success with quantum. We've hit a few bugs along the way. We were able to put in a few feature requests, which we've made some progress on. We weren't able to initially bind to our LDAP authentication service using...
You're using anonymous LDAP, correct?
Anonymous binding, yeah, right. So we modify our SSSD security configuration on our StoreNext workflow directors today. Another feature that we would like to have available is multi-protocol file access from Windows and Linux and Mac clients so that we can simultaneously share all of our experiment data to our users over SMB and NFS.
Okay, super. So as we mentioned earlier, you started out on what we call an unmanaged file system. That is, you were just taking your StoreNext clients and writing it to the disk file system through the metadata controllers. And then earlier this month, you got into this second piece, the archive piece. You purchased from us an archive-enabled library, what we call an AEL library. And that enables you to have storage manager policies. So for us, we have a couple different targets that can be relevant from a tertiary standpoint. You chose tape, but we also, I know because I met with you on this, so we talked about object a little bit, and of course everyone is looking at the cloud. What was your what was your decision-making process in going to tape as opposed to the others?
Yeah, we looked at several different options for that archive storage. I'll say that the storage manager functionality within StoreNext is one of the major reasons that we ended up purchasing StoreNext 3 years ago. We knew that capability to grow a little bit more cost effectively was an option with StoreNext. So when we talked as a team about what valid options we have for the archive, we wanted something that was relatively cost effective because we know our growth rate is increasing quite a bit over the next 5 years. And we couldn't pass up how cost effective the tape solution was. We have the option to vault tape to create multiple copies of our data on the library file system so that we can take some of those tapes off-site and provide a little bit more disaster recovery as well.
All right. Well, this is probably my last question. Going out on a limb here, you wouldn't be doing this for us if you weren't a satisfied customer. Would you recommend the StoreNext file system to others in DOE and at Oak Ridge?
Yeah. StorNext worked very well for our neutron science data needs. It's allowed us to grow without having to worry about several petabytes of spinning disk, which would get pretty expensive pretty quick. We had some reservations about the tape solution, and considered the more expensive the cost of the object and the cloud options. We've heard the mantra that tape is dead for a while now, but it's still a very, very cost-effective solution. And when it's used like this as an extension to the StorNext file system, it made a lot of sense in our environment. The files remain online. Users don't have to ask us to restore files. It just takes a little bit longer for those files to be retrieved from tape.
Great. Well, thanks so much. We really appreciate you being on here. It was great chatting with you. I'm going to kick it back over to Brett, and we'll let Jared show you how the components all come together with building a StorNext solution.
It's really nice to hear your perspective, and I also appreciate the candid feedback on what you would like with the system and some of those desirables, because I know our engineers will be eager to hear that feedback. I'm going to go ahead and pass things now over to our other engineer on the line, Jared House, so he can give you a little bit of an overview of some of the architecture behind our solutions and what makes a solution like Quantum work from end to end. Jared?
Hey there, guys. Thank you, Brett and John and Rich. That was real great Q&A. So let me go through and share some content with you so that I can show you what the building blocks are for how to make it work. We'll basically make work what Rich was talking about. So for all intents and purposes, to go back, sorry about the delay there, everybody. The StorNext solution is kind of, let's say, broke up into three parts. So you have your users on the left-hand side, you have your primary tier in the middle, and you have your archive tier or protection tier on the right-hand side. And so let's start in the middle, right? So in the middle, this is your primary tier of storage. And this can be anything from NVMe disk, can be anything to SSD, spinning disk, fast, slow spinners. It really depends on what your use case is. And it can be as large or as small as you need it to be based on your workflow and your use case. The Axelis workflow director in the middle there is really your brains of the operation. He keeps track of, the Axelis director keeps track of your metadata, where files live, where files are going, who's accessing the files. It keeps track of all that metadata that is who's doing what. Also in the middle, you have your disk. We obviously, Quantum sells disk. We have everything from NVMe to spinning disk and any type of speeds you need. But it could be somebody else's disk if that's what you so choose. If you're a shop that likes EMC or Hitachi or NetApp, then that's fine too as well. Now, I put it in the cloud in the middle there because StorNext kind of was a cloud, was basically cloud before cloud was cool, right? So long story short, what happens there, we virtualize, for lack of a better word, the storage environment. So your disk tier, whether it's fast disk, slow disk, anything in between, we take all that disk and we make what we call a file system. So for all of you out there, you'd see it as your G drive or an NFS mount or a local disk on the system, okay? So that's what it looks like to the users on the left-hand side. So we have all that disk, we make our file system, and it can be as big or as large as you want it to be. Now, on the left-hand side, let's move to the left-hand side where you have your users. What happens here is twofold. We have our ingest going on, and that ingest can be coming in over fiber channel, or it could be coming in over Ethernet, whether it's 100 gig Ethernet or whatever you choose, okay? So now you have your data coming in, and that could be any source of data. So for this, what Rich was talking about is neutron science. It could be DNA sequencing, it could be video files, it could be geospatial data. It doesn't really matter, but what we like at Quantum is we like large files, we like streaming content. So any of those are high-speed content. Because of the way that we do our disk in the middle tier is we can accommodate a lot of data really fast without dropping packets, without dropping data on the floor. We can guarantee it's available. So you have your ingest coming in. Down on the bottom of the left-hand slide, you have your users, your analysts, or whatever you want to call them. And And they can access that data content via CIFS NFS, like you're used to today with like a NetApp filer or something along those lines. Or you could do what we call our high-speed LAN client. What the high-speed LAN client makes the system look like to the user is it makes it look like you have a local disk on your system. So instead of it being a shared SAN storage, like typically people are used to having a SAN, now you have a local disk that is on the system. And the speed and the latency that's on the LAN client, it makes it seem as though that SAN storage is local on the system. And that volume or that share that you're working on could be 10 gig or it could be 3 petabytes. Really, it depends on your workflow. Okay, so now let's move to the right-hand side of our picture real quick. That's our archive tier. I'll go to the flow in 1 second here. If you look at the right-hand side of your picture, your archive tier, we have tape because that's what Rich is using. And a lot of our government customers, they choose tape because they have large data sets they need to keep for extended periods of time. And so tape works really well because the cost model around tape is really, really good when it comes to storing large content for a long period of time. So the tape tier is really there for that. So what happens is, now let's say the users on the left create a file. That file is streamed in over fiber channel to the disk chassis into the file system. Now we have a policy running in the middle here on this workflow director that says, okay, this file has now moved from here into our disk chassis, and once it's moved into this disk chassis, the file is now basically a policy engine kicks off and says, hey, I want to make a protection copy of this file immediately within 5 minutes of being on disk. So now it's on. So this file is now able to be written so the file is written into disk, it's now on disk, and we then take that file and it's moved on to tape. We make a protection copy of the file on tape, okay? So now users are working on their data and they're doing what they're going to do with it, and let's say after, 3 weeks, right, of the data being on tape, or on disk, it'll automatically truncate it or remove the data from disk and live in tape forever, right? Now the users over here, okay, they just see a directory. They just see a file has been written and it's saved. They don't know that it's on tape. They see it in their directory, okay? So now the file's in their directory. They said, in let's say 4 weeks from now or 6 weeks from now, they said, you know what, I want to move that file. I want to access that file. They will then click on that file and it pulls it back from tape back to disk, okay? And the users in this scenario, they may already know that, they already may know that their environment has a tape library involved in it, and they say, okay, if the file is more than a month old, it may be on tape, and it may end up being, instead of coming back instantaneously, it may take a minute or 2 minutes to come back because it's a large file and it has to stream it back from tape. Then if that's a problem, that's when users go and say, okay, well, let's put an object store in there because now you're putting it onto a cost-effective disk medium in an archive tier, and then your files come back much quicker because you don't have the latency of tape. But so it goes back to your workflow. So, in general, we like to look at workflows and what are the customers trying to do with their data, and what makes the most sense. Do they have a high-speed need? Do they have a long-term retention requirement? That's where this quantum solution that we talked about with Rich makes sense because they're all Lego building blocks, and you can make it fit for what your use case is. If it's a lot of users that need to access the same file concurrently on different operating systems, that's what quantum can do. If it's a large data set that needs to be stored forever, we can do that as well. Is it a lot of users that only want high-speed disk and no archive, but they need to guarantee that data is accessible all the time and they're not going to drop packets? That's what quantum does, because that's what we do with our virtualization in the middle and on the back end and the front end, so that the users can scale out or scale up based on what they're doing or what their need is. So those are kind of the building.
Aaron, there's a question. Can you keep a a local version on tape and also send one to the cloud?
That's a good question. So yes, so there's a million things you can do with StoreNext, and one of the options is on the back side of this diagram over here. It can be tape, it can be Amazon C2S, it can be Amazon's Glacier, it can be on-premise object store, it can even be a replicated copy of the content in your disk tier to a secondary site with a tape library or cloud, or name your system, right? We work with Azure and Google and Amazon. And so you can set up that tiering policy where you have a file come in to it can live on disk, that data that can then move to an Amazon S3 bucket, where it may live in Amazon S3 bucket for some said period of time before it then gets moved off to Glacier. And then we can it's the same process where a user sees the file. They may have a longer policy maybe set for a longer period of time. The data is kept on disk before it's removed completely, just so that, because the time to pull it back from Glacier can be lengthy.
Yeah. And StoreNext is managing that all the way through out to Glacier, yes?
That's correct, yes. And in some cases, we actually have customers in the space that I cover that they actually have their Amazon S3 bucket on the front end. So they have an Amazon S3 bucket over here in this ingest side. They do a lot of work, and then they move the data from Amazon's bucket, S3 bucket, to the file system, because the file system can see that bucket. It grabs the data after 15 days of not being used on S3, moves it down. It may sit here on disk for some set period of time where they have analysts that are working on it locally, then gets moved out to tape library for storage forever.
Yeah, that's kind of an upside down model, right? You're doing a compute up in the AMIs in the cloud, and then bringing it down here
to store.
And you've got a customer I know that's doing that, right?
Yep. And so it just, honestly, just goes back to what works for that individual customer's use case. They had a need for on-premise work, and they wanted to keep it on-prem forever. So
we have another question here about site-to-site replication. Can you talk a little bit about that?
Yeah, so let's take that for an example. So right here, let's say this is like a 3 petabyte disk chassis with a StoreNext environment with a tape library. Now let's say we take this same exact environment and we take the workflow director, and it could be a single node or dual node because we have an HA pair here where it has its own independent metadata. But let's say your remote site is only for archiving, and your tape library is going to be your remote site. Your primary site is a disk-only file system, and it's a larger 3 petabyte disk. Now we can take a single-noded Axelis or a dual, depends on what you want. But let's say, for example, because it's a DR scenario, you could take a single node system with maybe, let's say, a couple hundred terabytes of disk, move that over to a secondary site over here with our tape library. The data, once it's replicated, we have a replication policy that says, after, on schedules, and says, I want to replicate all this type of data or everything in this directory, or you pick and choose your policies. We replicate the content. We call it flex sync. We flex sync the data over to a secondary site where it then lives on disk for some said period of time, but it ultimately writes off the tape. So your data is protected at your secondary site and not on your primary site, if that's what you choose.
Gotcha. So in Rich's case, if he had access to a data center rack at, say, Brookhaven up on Long Island, he could do that if he had a second system.
Yep, he could flex sync. And I have customers that flex sync certain subsets of data. So they say, we don't want to do the whole thing. We really want to do this very specific, output that we've created, and this subset of data we're replicating or flex syncing to a secondary location and they actually have users at that secondary location that are using that content. So I guess the big thing here is, if there's more questions, we can address them. But I think the big thing I want users to understand is that this is configurable. The StoreNext environment is configurable to whatever your workflow is, whether it's small, humongous, slow, fast, need for archive, on-prem, need for object store on-prem, need for cloud. There's a lot of ways that you can make the system work for what you're trying to do. It's not just a one-size fits all. It's we talk to you, figure out what your workflow is, and we come up with the best possible solution so that you have a reliable system.
Thank you. Really appreciate all the feedback that Rich, John, Jared, all three of you provided today. It's really insightful. I know that our customers are getting a lot out of this, and we will definitely be following up with them because Quantum has a lot of abilities to come in and consult and advise and be able to help with your tiering methodologies or your storage, your file systems. There's lots of different things. We also have great video surveillance, autonomous vehicle, and ruggedized equipment. There's lots of other solutions that Quantum has on our line card. And with our recent acquisition with ActiveScale, there's a lot of stuff that we can do now that we couldn't have done before. So I encourage you all to visit our website at the conclusion of today's webcast. Your browser should automatically direct to the Quantum website, so don't be alarmed. And if you have any questions, you're welcome to reply to any one of us on the webcast today, and we will be sure to follow up with each and every one of you as well. With that, I'd like to give the opportunity to Jared, John, or Rich for any final thoughts, and just to wish you all well with the current situation and the global events that are occurring with us. We're very, very blessed to have you all here with us today.
Yeah, I would just like to say thank you to everybody and stay safe.
Thanks, Brett.
Thank you all very much, and this concludes today's webcast. Have a great day.